So this time we're still working with waves. Specifically, we're working with sound waves still. And we're going to talk about the intensity of sound. It kind of is how loud do we perceive the sound. It's kind of how much energy does the sound have. And there's a couple things that it's going to be based on. So part of things is we kind of need to go back and look at what is a wave. And the most basic definition of what a wave is it's a transfer of energy. If we're talking about mechanical waves, we know that waves transfer energy and not matter. Like if we're talking about a sound waves moving through like a block of wood, it's just going to momentarily bring those wood particles closer together, then they spread out and they're going to go back to where they were. And it's just the energy that's moving through the block of wood. So if we have energy, and if we're producing sound over a certain amount of time, we can go back and revisit the idea of power. Power was measured in watts. We used a capital W for that. Also, we know that to figure that out, back in the day, we talked about how power was how much energy was transferred over a certain amount of time, or how much work was done over a certain amount of time. Don't get these W's mixed up. This is watts. And we know both of these were in joules and time was in seconds, so the other unit we could use for power is joules per second. So if I'm going to refer back to the question down there, it's about a trumpet, okay? A trumpet's being played. And so if I'm just blowing into it, producing a continuous note, I am producing sound waves that are transferring energy. As I'm doing that, we can measure how much energy is being transferred each second. We can measure how much power that trumpet is giving off, or the trumpet player and the trumpet are giving off. And so that's going to be a big determinant for how intense these sound waves are. What's going to have a bigger effect on intensity, though, is how far away the observer is from the sound being produced, because that's going to decrease exponentially. It's going to decrease by how far you are away squared. So typically, like the way that we kind of think about it is, think about it like we're looking down on kind of a football field. Like let's say we're at marching band practice. I'm gonna totally, but actually, that's not a horrible trumpet. All right, I'm pretty proud of myself. Okay. We know that as this trumpet player, he plays, he's going to produce sound waves that kind of emanate out from this point. And it's just going to travel out around. That last one was pretty bad. And so the sound waves themselves are actually getting spread out. Like the amount of area where we're going to have our compressions and our rarefactions and stuff, those sound waves get kind of stretched out. And that kind of explains why it decreases exponentially. So really it's just that distance is going to have a huge effect on how intense a sound wave is. So let's just go right into that question down there. So what is the intensity of the sound waves produced by a trumpet that is at a distance of 3.2 meters when the power output of the trumpet is 0.2 watts? All right, so let's just lay out what we have. So they give us a distance or a radius of 3.2 meters, and they tell us that the power output is 0.2 watts. All right, so power is 0.2 watts. All right, so they want to know the intensity. And I don't actually know that this actually has a shorthand for it. So it's more than just a three variable. I mean, it does have three variables, but we got this 4 pi kind of constant there. That 4 pi part just kind of helps us factor in essentially the area of the circles that we're kind of cutting out there. So let's just kind of plug stuff in. So intensity is equal to the power we said was 0.2 watts over 4 pi and then r squared. Thank you. All right, so the r squared part is going to be 3.2 meters squared. And I'm actually going to throw brackets around that denominator just to make sure I get my order of operations right. Assuming I can actually operate the calculator for once. All right, so let's go ahead and bring up that thing. Bring it over. All right, so we're going to do, I'm going to do the 3.2 squared part first, just to make sure I can get that down. All right, 10.24. So let's even go get that written down just so I don't forget it. So I've got 0.2 watts over 4 pi 10.24. Now keep in mind that square is also going to square my unit there. So meter squared. Pop that in parentheses. Bring the calculator back over. So I've got 0.2 divided by parentheses 4 times pi times 10.24 close parentheses equals 0.00155. All right, so bring that over here just so I can remember that. So I've got 0.00155. Okay, so that's the intensity. And 3.2 meters away isn't that far away. So my unit here I'm going to go with is just watts per meter squared. There are some kind of cool things that occur if we start to do some unit analysis stuff. So I'm not going to bore you with that here, but if you're in class, you might be having to deal with me doing that. All right, so the equation is actually pretty easy to follow. Sometimes what's kind of important is like if I'm stretching here, like for microphone work and stuff, if I need sound to be of a specific intensity when it reaches my microphone, and I know how much power a certain sound source is producing, we could go through and figure out how far away that microphone should be from the sound source. I can't think of a real situation where that would be used, like, because for the most part, if you're doing sound work, you're just going to just do trial and error. You're just going to put it in position, try it, see if you get the right recording you want, move it, stuff like that. Like I said, that's a stretch. That is just how we find intensity, which is kind of useful, especially when we start talking about like the decibel scale, which is just kind of you just go to a chart and it helps convert from intensity to decibel, which is kind of an easier way to think about how loud something is. But we're going to save that for in class. So, good luck.